All right, good morning, everyone. My name is Jasper. I'm the Growth Marketing Manager here for the cloud at ADB. I'm going to be your host today for our webinar, Streamlining Database Provisioning with DevOps. Today, I'm joined by Doug Ortiz, our Postgres DevOps engineer. But before I turn it over to Doug, I have just a few housekeeping items to go over. Firstly, this presentation is being recorded, so we are going to share the recording along with the slides with you after the broadcast. Give us maybe about 24 hours to turn that back around to you. Secondly, please note that the lines are currently muted on Zoom. We do expect the presentation to last for most of our time today, but any extra time that we do have at the end, we're going to use for Q&A. Throughout the presentation, if you do have a question, feel free to submit it to the Q&A panel. I'll also be scanning the chat for the questions, but it's much more likely I'll lose track of them there. That Q&A panel is your best bet. If we don't have time to address all the questions, I'll follow up afterwards with any attendee whose question was not answered. Okay, Doug, with that, that's all of my housekeeping items done. I'm going to turn it over to you to kick us off.
Thank you. Hello, my name is Doug Ortiz. I'm a Postgres DevOps engineer with ADB. And that said, not surprisingly, we're going to be talking in our webinar about streamlining database provisioning with DevOps. A lot of these topics for many DevOps veterans or seniors, we're going to be just brushing and up a few concepts on DevOps, just refreshing them. And then we're going to get into the meat of the webinar itself, which will be DevOps for databases. But that said, we're going to be touching a few topics of DevOps, such as what DevOps is, its definition, benefits, the core values and principles. And then when we touch DevOps for databases, we're going to be looking into the pipelines, considerations, reasons to implement, a demo analytic of our demo itself. We're going to analyze the code and see the results of it. We're going to look at the principles and tools as well applied for DevOps for databases. That said, let's get started. So we have here two parts. Where does DevOps come from? It comes from two terms, development and operations. As you probably already know, we have already two parts here mentioned, development and operations. That said, we have already these two terms that have been defined, and they come from already probably everyone on the webinar knows. It's a coined term from Patrick Dubois and Andrew Schaefer. They coined it in 2009, and they had a lot of discussions. They're really the gurus behind all of this. There's a lot of these parts and items that some could discuss and keep on talking about, because some even refer to the operations for each intra-department, meaning each department could have IT operations, financial operations, banking operations, HR operations. The same could be said or inferred about development. So keep that in mind, because many times, whenever DevOps can be applied at the organization level, enterprise level, or at the department level. That's one thing to keep in mind, to not be confused sometimes. Next would be, since we don't have any specific definition here, we have to really borrow or start from some starting point. One term could be, it's from a practice of operations, to get the entire teams of engineers and operations working together with a goal in common across the entire development lifecycle, starting from planning, design, process, up the way to production and support. Then we move into philosophy. It's a philosophy itself for software development. Some add a few more other definitions in there and words, but that's really at a very concise point. Others also refer to it as a culture that is around collaborating, comms, culture, automation, lean, measurement, shareable, all of those together. Also, some refer to it as a culture centered around collaboration, communication, integration, and development, operations, and QA teams. That's another way of defining it. Also, last but not least, a set of tools and practices. What types of tools and practices for streamlining, building, testing, deploying your software at a much more scalable level, reliable, and with less errors itself. One other item to keep in mind is that DevOps is ideal for containerization and microservices. That's one of the reasons it has become so popular as of lately. Well, it's been around for some time. It's already know that. So once we've talked about the definition of DevOps, let's look into the benefits that we can expect from it. There's a couple of things that we can expect here. For instance, on the main side, we have a few advantages, competitive advantages. Then we have even more benefits here. But the most important ones to keep in mind is it improves IT performance. Your code deployment itself goes faster. You reduce the failures, which in turn the reduction of failures means faster deployments, shorter development life cycles, and increased stability. The users will actually benefit from it because they will feel more confident and trusting with what you're deploying into your pipeline and the output itself. Releases will be higher quality, and that's one thing to keep very much in mind. How do we do this? Well, we use a toolchain, and it's an infinite loop toolchain, as you can see there. Where do we start here? Well, this toolchain has a variety of items to take into account. You start with planning, you then move into code, build, test, release, deploy, operate, monitor. Our entry point is here most of the time. That's when we start planning for our builds. What do we want to add? Stories, depending on whatever planning tool you use, Jira or Agile system, that's what you're going to start planning. We're going to add or remove a bug, depending on what you're trying to do. We're going to add new features. You plan for it. Then you start moving into the coding. Then you build it and test. Tests, of course, would be conducted hopefully in the pipeline. Then they'll be released if it's all successful. It'll be deployed and then put into use and monitored for later usage. That's where the toolchain comes into play. Let's take a look into our core values, re-examining. And here we have to give it a little bit of thought here. What are we thinking of? There's culture, there's automation, measurable, and shareable. But there's also a couple of other teams that call it comms or clams, because think about it this way. Lean was incorporated, and that's where the L comes into play. It was not originally part of it. And the reason they incorporated lean was because it brings a lot to the table. It eliminates waste. It amplifies its learning life cycle within an entire build, which is something that everybody can benefit from. It adds to the equation the decision-making, whether it's as late as possible or as fast as possible, empowering your team at the same time in the entire process or the tool chain, integrating builds and seeing the whole perspective. So no longer you just focus on one little item, you're just seeing the entire whole. That's where lean was incorporated, and that's the biggest reason it was incorporated there. Now let's take a look at the principles. With the principles, let's take and see what we can learn from. With system thinking, it's a way of being analytical, really. That's what it means. Those three aspects. System thinking, try to see the whole perspective when you try to solve a problem. Why? Because it's great to focus, but sometimes when you focus on just one little item to be fixed, you lose the perspective of the whole. Keep that in mind when you're going through the DevOps principles. Then amplifying feedback loops. This is a great part to keep really in mind and being looked into. Think of it as the whole purpose of this principle is to catch as many errors as possible so that you can prevent these following you or encountering them down the road in the pipeline or the process. So think of it as a fishnet. If you are using a fishnet to catch your errors where you fish, you're going to grab a lot of them versus using a fishing pole. You're just going to be using one fishing pole, grab one error here, one fish. If you're lucky, 2 or 3 of big fish. But a fishnet will get you more variety of fish and errors in this case. continuous experimentation. With continuous experimentation is expect errors. That's really what it means. Expect failures, expect problems on the way. Why? That's just part of the process. Don't get frustrated. No need to blame. And that's, of course, leads into blameless postmortems that we won't be talking much about them, but that's something to keep in mind for usage, because nobody should be blamed. Everybody's learning. We're all going through the same process at the same time, and it can be frustrating. But once you remove a lot of those problems that you encounter, you will see faster performance and increased and reliable builds and releases, which that's the whole point of everything. That said, what can we see as the benefits of incorporating database provisioning into our pipelines? Well, incorporating our databases builds here, the main reason is because you can apply DevOps, all its culture, philosophies, processes, ideology, culture, to the same ideology of databases. They can be merged, no problem. You just have to have additional considerations, because these processes were usually assigned solely to teams of DBAs or DBAs themselves. They used to be the bottleneck. Why? Think of it, on one side, you had the development team, and then you had the DBA team. Whenever you needed a database, you would throw paper or ticket, whichever process you had, and request a database, tables, views, all the objects that you needed, with the data hopefully incorporated. How long would that take? That would depend on how busy they were, their timelines, their deadlines, whatever they're really at this currently task assigned. You're going to be in the queue. Well, the whole idea of doing this is no longer going to be a problem, because you're going to be tackling these two at the same time. The reasoning behind it is, well, it's not going to hold you back. And I'm not saying you're going to no longer need the DBA teams or DBAs. Just saying that you're going to be able to both collaborate much more seamless, more straightforward, because they can be creating scripts, scripting the database, the objects, the data inside the database, and all of its objects itself. That way, you have all of that together, version controlled, scripted. But there's going to be a few things that you're going to have to consider for the next step about that. And those steps are going to be the considerations. What considerations are we going to need? First, it's going to be a learning curve for DBAs. What does that mean? Well, they might not be as versed as the development team with version control tools. That's a possibility. They might be very versed with it, but in many cases, that might not be the case. They might not even have a lot of scripts. I don't know exactly what they might at times be using, scripting or not scripting, version control or not, but many times they have their own methodologies, and it'll take a little bit of time for them to adopt DevOps and get an understanding of the whole of it. Doesn't mean it's going to be forever, or it's going to take years. It might take a little time, and they might need some hand-holding, but in the end, it's going to pay off. The tools that are going to be involved are going to be around the pipelines, version control, testing. Testing is going to be of high importance, and we're going to see that later on. We incorporated tests in our demo, so we can eat our own food here too. So that said, what do we think about next? Why should we implement DevOps for databases? Well, there's two sides of the coin here, as you can see. One is for data purposes, for automating the data, putting it in a pipeline. Once the pipeline, if it is successful, you have a database. And what's the purpose of having that database there? Well, for your applications. It might be that you version or target your databases and its data content to a specific application itself. Maybe it's for banking industry. Maybe it's for finances. Maybe it's for sales. Each one of these might use a different database. Before, you would have to request again, I want a database here ready, and have your application that's already built by your pipeline and delivered point to the database whenever it's ready. That would no longer be the case. That means You're taking into account everything from application to database. That's one of the biggest benefits and reasons to implement. You end up treating everything as code. That sounds familiar, doesn't it? Infrastructure as code. That was a bit harder to really overcome that hurdle before a few years ago, whenever it was really difficult to get an abstract idea and concept of infrastructure as code. The same applies here. You end up treating data as code. Tests. Second time I mentioned it. Unit tests for data. That sounds a little weird, does it? But it's not. It means apply tests. Actually, not only name it unit, there could be logical tests. That's another thought there. Any kind of test that ensures data quality. All these tests, that's the main focus, data quality. Then we move into the database. What another reason to implement it? Well, what kinds of reasons? You can create baselines. You can prevent drift between the data itself because you can version it. You can script it. Why? It's in source control. If you want to add more data, modify it in the script. Then guess what? It's going to be versioned. It's going to be automatically available for whenever you create a new build. Cleaning up is going to be easy too. Why? Because it's going to be automated and scripted within the pipeline, not to mention rollbacks. Bottom line, data being treated, let's step back there. Treating your data as code is going to pay greatly down the road. So how do we apply the principles of DevOps for databases then? Just like you apply DevOps, the principles, you can apply them to DevOps for databases. The same three principles we saw before. System thinking, first one. Then you amplify your feedback loops and continuous experimentation. They apply the same way. As we can see, you see the hole here, and then you amplify that fishnet or way of grabbing as many errors up front as possible and keep on trying. That's really where it all keeps on paying off. Keep experimenting because it never ends. That's why it's a tool chain that you see, it's infinite. Which kind of tools can we expect to use? There's a variety that we can see here, but the main one is going to be your source control. That's the starting point. Where we saw in the tool chain or planning, guess where the planning of that, the story or build will be. It's going to be committed into a source control tool, whether it's GitLab, GitHub, whichever you use, that's where it's going to be your center point, which of course leads into GitOps, but that's a story for another time, another day. That's where everything goes, source control. That leads into schema source control. Your data scripts, you're going to be scripting them, versioning them, controlling them as well. Now, we're talking about tools here. So where do other tools, third-party tools come into play, or open source tools? You have a few such as Liquidbase, Flyway, that you feel free to look them up. And what they do is help you version your data and objects through steps in the process and committing them. It'll push them automatically for you. It's a way of version control, but without the version control, relying on the tool itself. Feel free to look at it because it sounds a little strange, but it's very effective. Another tool that's very useful is Faker. It's written in Python and you add it into your Python code and allows you to insert data, select data, create test data. It's useful enough. And then you have other tools that we probably, if you've been doing DevOps, you've heard about Terraform. There's Ansible, Puppet. And of course, at EDB, we have a few other tools, such as EDB Postgres deployment and our EDB Ansible as well. So for some food for thought here, start considering your questions for submission because we will be answering them right after our takeaways. Last but not least on this topic, DevOps tools for databases. You've heard about them before, one way or another. Containerization, widely used as Docker. You have orchestrators, Kubernetes, OpenShift, source controls, and job scheduling. Okay, that said, let's go ahead and take a a look at what we're going to be looking into the demo. In this demo, we're going to be walking through an example. We're using Big Animal cluster, a Postgres version 14 Big Animal cluster in Microsoft Azure backend in a Big Animal cluster. What the pipeline is going to be doing is a GitHub Actions pipeline, and it will deploy a database via a commit in our source control. It'll make a change. We'll create the commit, and it'll spin off the pipeline. In the end, we'll have a database and objects within it itself. So let's go ahead and take a look at that. I'm going to take a moment here and share video. And here we go. This is what Big Animal interface looks like. You can see overview, clusters, admin, and activity. Feel free to request a free trial if you would like to learn more. I'm filtering here all my clusters based on my initials, just to keep it kind of tidy there. Notice we are looking here at a cluster that is fully healthy. It is also, as the cloud provider is mentioned before, Azure, has public access, 3 instances, a version of PostgreSQL 14, high availability is already baked into it, and it is available in US West 2. What we see here on the screen is just an overview of how you could connect using the pSQL statement into your Big Animal database. For our purposes, we're going to be using pgadmin, which is also a tool that's quite widely known out there. We can see, we move here and see all the items. And then we're going to proceed to look at our source code. This is the entire repo. Just scrolling down to show you. The link is available and we'll send it to you. The code, you can also play with it on your own. And the first SQL script we're going to look is drop objects. It drops the database. Now, this is used for idempotency. The second one, we're creating the object. I'm going to pause here. And I talked about idempotency. Your pipeline should always be idempotent. In case we're not familiar with the concept, it means that how many times and however runs you have in the pipeline, the end result should be the same. There should not be any discrepancies. I will run it the first time. In this case, my purpose is to get a database with its objects. If I run it a second time, I'm going to get the same database, same tables, same objects, and same data. You keep on, you can run it 100 times if you want. The results will be the same. That's idempotency at its best. So now we're going to do a review of another SQL script called create table. Now, if you've been looking here, taking a careful look, I'm not only looking at the SQL scripts here, that adds data there. We're going to be looking and scrolling down after we finish the get data SQL script. We have more scripts in there, not only SQL. Look, we have there bash scripts. So what's happening here is I'm going to use these SQL statement scripts as points of entry, as separate subtasks. And the main task will be in the bash script. Let's take a look at the provision script. Not a good practice, as you can see here, I put a password, but for demo purposes, that'll work. I am setting my password, my IP address, the user, the instance, along with the provider and the region. All this came from our portal that we saw previously. Then if we look here, I'm dropping the database objects. I'm creating a bash statement that sends the password, the user, the IP address, it can connect to it, and telling it, I want you to execute the code in this SQL file. I want you, after you've completed successfully the step, also in the pipeline, there will be an output. The result will be displayed. The next one, same thing. Now, this time, the difference is we're going to have creating the database objects. followed by creating the table, and last, adding data into it, the inserts. Let's see the next step then. The next one is get data. And that's going to sound familiar. All it does is, of course, is what we explained before, but it's going to get the tuplus, meaning what I'm trying to do here, well, what I'm accomplishing here is a test, a logical test. Take a look. I'm creating and setting it up to find if there are tuplus. I'm setting the variable to 0, turning off echo, getting the tuplus, calling the get data script that we saw before. All it does is select count and from a specific table. If there are any tuplus, it will display, and then it will continue with setting it up into the GitHub environment. So I can reach out to it later on. We'll see how I'm leveraging this as well. Because now, the fun part, the pipeline. Here's where things are going to be. And it's very, very small. Let's start looking. 1 year, I was lazy here, to be honest. And I'm using a self-hosted runner. There's multiple types of runners. Self-hosted is the one that you can reference and leverage your virtual machine, or in this case, that's the way I used it. Whatever you have installed, packages, tools, they will be available for you. They're readily available. That's what self-hosted runner means. You can choose not to use a self-hosted runner and leverage containerization, which you can create an image that gets spin up, starts, has all the available packages ready for you, and executes the process itself. So this could be done differently, a little bit differently there. Then the first step is I call provision SH to create the objects. The second one is get the tuplus. We were talking about that. And last, this is my logical test. This is a key item. Why? In here, I'm going to be verifying. It is a logical test. Remember I mentioned that before? And all it's verifying is that if the pipeline was successful up to this point, up to where no tuplus were found, then that means if the tuplus, the records are 0, it failed. And then it means I have to cancel or quit the pipeline. Nothing wrong with that. Just what's the point? Following the principles, remember? No broken code should be committed, and the pipeline should be successful. If it's not, roll back, fall off. I was lazy here. I didn't do a drop of the database and leave it clean. So I broke my own rule. I failed to follow the rule of committing, cleaning up after any errors are successful, or if they occur at all. So there you go. I am at fault of that. I am to blame for that. Now, let's go see this pipeline in action. For that, I'm going to have to open a terminal and first start my runner. There's more details of how you can create that self-hosted runner in GitHub, but this is how you execute it in the end. Once it's running, it tells you it's listening for jobs. So now I'm going to go into my code and I'm going to make a modification. I'm going to modify the comment there. As you can see, we're looking at the status, we're adding it, writing the commit there with a more descriptive comment there for the commit. It's going to be pushed. Now that that has happened, let's go see what the actions are here. This is going to show us that it was kicked off. The comment was used as a name for the pipeline. We click on it, so we're going to be drilling down. We see on the left-hand side the jobs and the workflows. And now that it showed up, we can click on it again and drill further down. Tells us it's starting the job. We'll go step by step. A lot of times, when it waits a little bit, you have to speed up the process, and that's what I'm going to do. As you can see on the left-hand side, it says it started and completed successfully, but it's not entirely showing up there. So I'm going to refresh. And now it shows up that they've succeeded. It was faster than what we could imagine. Let's take a look at the details. It was successful in creating the objects. Also with getting the 2+, we got 3, and it displayed the 2+, saying it found 3. Notice here something important. No 2+ here found was not true, meaning the test questioning if they were 0 2+ was not met, which means that's the reason the pipeline is great. Let's go and verify this. The job was pipeline succeeded completely, and we can see in green. So that's everything is off to the races there. And we can see that there's no database. Let's refresh. There we go. We have a demo database. That was not there. Now we're going to open the schemas, then the tables, and we should see one table. There it is, salespeople with columns, 2 basic columns, salesperson ID and name. Now let's look for the rows. There should be 3. 3 total there. And there we go. It takes a little bit, but there we go. Successfully, we've seen that happen. That takes care of part of the demo. I'm going to reshare my screen. And now that we've taken a good look at the demo, let's start looking at the takeaways. What have we learned so far? Let's see what we can come up here. Well, we have 3 areas. One for recommendations. While we were doing the demo, or in previous slides, we were talking about one recommendation: break your scripts by task. Why? It's easier to segment them. It's easier to address them, to modify. When they have a single purpose, it's easier just to go one single script, modify it, and you know that that's where things break or succeed, or the comments can be added. You know where to go. If it's also, of course, named mnemonically, that will be easier to debug and modify later on. Add tests to your pipeline. That will help you immensely. You saw that I could have done the pipeline without a test. That would have worked. But if I add additional tests, that helps me verify and ensure I'm going the right path. If something is successful, a pipeline is successful, it ensures that. How many tests? That depends on your needs, on the project, on the application, on the pipeline. Only you can answer that. But nevertheless, add as many as needed and as possible to keep you in sync, for cleanups, to prevent any other areas, because as mentioned before, they should be idempotent. Consider third-party tools if you need to, because these third-party tools might help you in the linting process for testing, unit, integration, data testing. All of those might come useful there. Also, we were talking about source control. Well, with source control, leverage branches. Why? Because it's going to help you and your other peers whenever you're all working on the same main branch. Will not be easy and will become messy very soon. Create separate branches for each user and each feature, if this case. For instance, Doug feature 1, your branch. I will focus on their branch. Somebody else works on feature 2, Jack feature 2. This will make it easier to be accountable for what has been delivered. But not only that, it's going to be easier to merge later on. Also, tests, back to tests. Coffee test metric. What does that mean? It doesn't mean, usually it could be taken multiple ways. Whenever your pipeline starts executing, you should come back and see a result. How long does that result take? That can be the part of the coffee test. It could be that you already had your coffee there, mug waiting, and you just pick it up, done. And as you saw in our case, it was so quick that that would have done the trick. It would have been less than a minute. In other cases, your pipelines are going to take a lot longer. Why? Nothing wrong with that. It just means they have more items to build, deploy, test, add into the equation to go through. Meaning, have a measure to know what is best for your pipelines. That's really what it means. Have a measurable way of seeing if it was successful or not. Keep your commit small, going back to source control. And we spoke about that, no broken builds. Why? Because they're just going to cause issues. If you don't test locally, whichever developer is working, as mentioned with branches, they should create a branch, work on it locally, test it enough locally, make sure that it works, that it's not broken, and then submit it for review. Of course, it never hurts to have in the pipeline tests to prevent a broken build, because otherwise you're just going to be spinning headaches trying to fix what's the reason pinpoint, the reason the entire pipeline broke. Your deployments, as mentioned before, should be idempotent, meaning you can execute them as many times as you want or need, and they will produce the same result. Our takeaways could also apply to multiple areas: development, testing, collaboration, and the deployment itself. What are the outcomes that we can expect here? Well, we talked about it before. Data ends up being treated as code. It becomes testable. You can add tests to verify if data exists at the end of the pipeline. For instance, we had 3 records. We could add a test to say, maybe they want to know, or part of our requirements is to know that there is a specific record available at the end of the pipeline. You can add that as a test. We just quickly did something similar. You can verify that way as well. Also, version control. Keeps on coming up all the time. Use some tool. Versioning, source control, that will take care of it. Be familiar with it. If it's not implemented, then you need to implement it. That's just one other part of it. And when it comes to releases, they're going to be, of course, leveraging source control. They're going to be incorporating also data ready. Your data is going to be clean, going to be good quality. It's going to be ready for whichever purpose you need. It also can be versioned. The database, its objects, and data that comes as the outcome of the pipeline itself. Bottom line, your releases are going to become more flexible. That's the first thing. Faster, robust. And of course, we mentioned that again, data ready. Everything is going to be automated, so the processes can scale up. It doesn't have to be a small application. It can go much larger. It can be even application-wise. Okay, that said, I hope you're ready and have some good questions, because that's where we're going to right now.
All righty. Excellent presentation there, Doug. We definitely have a couple questions here. So I'm just going to jump right in and start asking you. So first off, what's your advice for standing up a new and successful DevOps process? And I've gotten a lot of questions similar to this. So some of the other questions like that we're asking, what are some of the pitfalls of setting up a new DevOps process as well? What's there to avoid? That's
a good question. A lot of pitfalls. Always verify, look at errors. What do you want to target? What do you want to address? What do you need to automate? The principle there of system thinking, be analytical. So taking a step back, you start thinking, well, what is it we're trying to accomplish here? At the enterprise level, is that at the level that we want to be? Do we want to do it at the just department level? Start from asking these hard questions, big questions, and start narrowing them down. Of course, incorporate into that everything we talked about here. Source control, tools if you need them, tests, linting tests to make sure your code is accurate, logical tests, data tests, unit tests, integration tests. That would be a good starting point. In the end, incorporate no broken builds, standards, documented, and set the philosophy and the culture around that there are no fingers pointed to anyone, blameless postmortems, meaning whenever there's a failure, it's not about let's gang up on whomever made the page. Let's talk about it. Let's see what happened. Maybe he was having a bad day. Maybe he just made a typo. It could be something simple, small, but it's a learning process. Don't be frustrated. It will happen often, frequently, and more, but it's going to diminish. At the beginning, everything starts because as the amplifying feedback loops mentioned, the beginning, you're going to have a lot of errors. Your fishnet's going to grab a lot, and you're going to go little by little, targeting them, resolving them. In the end, they will diminish. If you follow the process, that's what will happen.
Awesome.
Hopefully that
Good answer to that
answered.
question, Doug.
Great. Nice.
So we've got another one coming up here. Why should we use databases with the DevOps pipeline? And then when we do, how do we get to streamline that?
Well, in the demo, we used GitHub Actions to create a pipeline. Why should you use DevOps for databases? Think of it this way. You have your applications and you have your databases. If you look at your databases, usually it's a very different point of view. You think of them as a larger object that cannot be version controlled or treated as code. They can actually. It's just a different way to target it and approach it. So if you have a pipeline that delivers your application and your database, you will have specifics. Think of it this way. Database V1. Maybe your version 1 of your database contains very specific tables or databases or schemas, views, or even as simple as records rows. The data can be specifically targeted. So by doing that, not only you're versioning your application, but you're also versioning your data all together as one deliverable, as a big box. That ends up being one way. And what happens with the next version? Maybe you added more data, removed data. You're segregating and having an immutable deliverable there. Hopefully that explains somewhat what we're trying to do there.
We're getting a lot of questions in as we're still going through Q&A, and I invite you to keep sending them in. So Doug, here's one that we just recently got. Do you have a suggestion about how to handle database releases to multiple database instances using a pipeline? We're talking on the scale of hundreds of databases.
Sure, separate versions of pipelines. So as we were talking before, you can have multiple pipelines and multiple releases in your repository, source code repository. There's nothing stopping you from creating multiple pipelines targeting these multiple releases. That might be a little bit of a development task for the scripting and how in your pipeline, but it is achievable. And by doing that within one center point, which in this case is the pipeline, and we saw it's the YAML file, if you code it in there, you won't have to be recoding or thinking about it too much. Think of it once, apply the system thinking principle. Think of it once there, solve it there, and that will speed up your process, even if it's thousands. If you're able to code it correctly, and there will be some errors at the beginning, don't take me wrong, there will be, but you will eventually get them out of the way, all of them hopefully, and then be able to deliver thousands of different databases, if even, or tables, etc. All of those are achievable. That would be my recommendation.
All right, great answer. Another question we've got here is, when we're working with a database, there's already a lot of data already in flow. How do you manage a transition to production when you can't just stop the database from working for a minute?
Well, remember we didn't talk about it here, but when I'm talking about types of releases, whether they're canary, blue-green, all of these different ones. But we did talk about different versions of databases. Okay, so in case you have a database version 1 that's in production right now, that's okay. You have a new pipeline that's going to have version 2 coming out. Deliver database V2. That's okay. You have V1 and V2. As you said, you can't stop it. But what you can do is in your application code, make a change, and whenever it's delivered, target V2. So incremental process. Once you make your tests and determine, okay, these things look like they're okay, it's working as it should, you can drop down and destroy the previous version 1 incrementally, and that keeps on going. It's an incremental process, gradual and incremental process.
Awesome. One thing I do want to repeat is, we've had a couple questions about finding the resources that Doug was showing on screen. We'll send a follow-up email today with all of the links there, and also a link to a big animal free trial so that you can start spinning up clusters there. We had another question here. Are you aware of any version control frameworks that focus on the complete database rather than focusing on migration specifically?
None that I can think of. The closest ones that's mentioned were Liquibase and Flyway that are just migration. But one thing is you could script something similar. Those tools have a lot of in common to add, but if you're looking for something more powerful, you might want to consider scripting something of your own. It shouldn't be that difficult. If you notice, it's a lot of scripts, but if you are able to make them more generic, that should go a long way.
Got it. That makes sense. I do want to also remind everyone that the slides and the recording of this presentation will be shared afterwards, just in case you want to review anything, or if you want to just go through the slide deck as well, share that out. That will be made available to you roughly about tomorrow. So Doug, we're coming up on time here, but I do want to ask just one more question. We've had so many good questions come in, and I see that we're not going to be able to get to everyone today. If we don't worry. I'm going to make sure someone from EDB reaches out to follow up with you to help answer that question. So the final question for today is, how do we encrypt passwords or avoid putting passwords in scripts? Like, how do we make sure that that's really secure?
Great question. You got me on that one. I'm to be blamed on that one, and it's easily seen in there. GitHub Actions and these source control tools have variables in their own repository. You could assign a variable there if you want to. You can even have them encrypted. So write them once there, and they will be picked up. You've referenced them in your script, in your pipeline, and that will work. That's in one way. There's multiple ways, but that would be one of the simplest ones. There's multiple articles out there how to use if you go into the settings and variables in GitHub, if I believe, that's where you would look more or less.
All righty, awesome. Well, we are just about at time today. Thank you everyone for the amazing amount of questions. Really excited to see that. I do also just kind of want to put out there that we are thinking about doing a DevOps, another DevOps presentation where instead of thinking about DevOps for databases, we're thinking about, right, how does DevOps lead into data ops? So I just wanted to put that out there, a little preview of what we're thinking about doing for our next webinar. But for now, I apologize to everyone whose questions we couldn't get to today. I'm going to have someone from EDB reach out to you to follow up on that question, but this is all the time we have. So thank you all for joining us for this webinar. Thank you, Doug, for presenting. We once again will be sharing the recording and the slides with you as soon as possible. Thanks again for joining us today, and have a great rest of your day.
Thank you. I'll see you soon.